is a turning point. Turning point actually is the like stationary point, they turn. Okay, let's see this discovery activity first. The first one. This is the curve. You are given negative x squared plus 2x plus 3. This is the curve, the pink color one. Okay, and the gradient of the curve, after you differentiate, you got the gradient function. This is straight line, is a gradient of a curve. When it's at point here, this is a point when x equals to 0, you get this one. The gradient is positive. When you up here is positive. If I move my point P to, you see, okay, all look at here, P 1.17 here, positive. Okay, if I move my P, you see 0.5900. If the straight line, like this, the gradient will become 0. Okay? It's like lying down horizontal, gradient becomes 0. Okay, then it follow the curve. It turn to right hand side here, the gradient become negative. That means the P from here, the gradient from left hand side here, from positive become 0 and become negative. This is a gradient. Okay, this show that when the curve like this, we say the concave downward, like an N shape, the gradient will be changed from positive to negative. Okay, if I change the A is a positive here, then let's say this I put negative. I follow the textbook, textbook discovery activity. Your curve like this. Now your curve is positive U shape. Okay, the curve U shape. So, oh sorry, become smaller. Why it zoom in already? Okay. So the curve is U shape. Now you see my P from left hand side here. You see negative. Is negative. And then if I move my P, move here, okay, it come like this. It becomes 0 when you horizontal 0. Negative become positive. You see the turn here. Look at here the P. Negative. This is a gradient dy dx. Dy dx at point P. Dy dx at point P. At left hand side here, it is negative. So when the curve is minimum, when the curve like U shape is minimum point, it will change the dy dx from negative to positive. You change the dy dx from negative to positive. Okay, remember this thing first. Okay, next. If I change my curve to power 3 and B0, C is 4. Okay. Now my curve is like this. This is cubic curve. Cubic curve. How to become, okay, cubic curve. So now you can see the P here, the P here from positive dy dx, whenever horizontal dy dx equals 0, and then it go here also positive. That means the dy dx never change. Dy dx from positive, it's still positive. So this one we call point of inflection. It's not point of minimum, it's not point of maximum. Okay, so there's a 3 example I show you just now. Let's see. Okay, this is finished. I follow this 3 curve. Activity, discovery, activity 7. Okay, now see. If the sign from positive to negative, if this is a maximum point, your dy dx will change from positive to negative. If your point is minimum point, your sign will negative to positive. Because dy dx is a gradient. Gradient, okay, dy dx is equals to gradient. And last time you learned already gradient like straight line. This one straight line positive. And this one go down negative. So it go up positive, go down negative. So if it's from negative to positive, it will be minimum point. From positive to negative, it will be maximum point. If never change, positive to positive, If it's turning point, we call point of inflection. This one point of maximum, this one minimum, this one point of inflection. Okay, let's see this one. Generally, if the point from the curve like this one go up, go down, okay, then this dy dx will be equal to 0. I draw another one. Okay, this one finish. If going up, positive. If going down, negative, the gradient. Okay, now I draw another curve like this. I follow this one. Point inflection like this. Not nice. Sorry, again. This one go down. And then go down some more. Okay, this one up. Something like this. Okay, now we see dy dx first. First derivative. Dy dx. If here, straight line here, sorry, there are no ruler, so not nice. Dy dx equals to 0. When there is a maximum point or minimum point, dy dx equals to 0. Remember, maximum or minimum, dy dx equals to 0. This one must remember. Second one, if dy, okay, the dy dx only, dy dx, if going this like positive, this one go down negative, going up, so dy dx going up positive, going down negative, up to down, it will be maximum point. Okay, this one going down also, dy dx going down also negative, this one go up, dy dx going up positive, right? Down and up, this one. So from negative to positive, it will be minimum point. This one is referring to dy dx. Okay, now I want to add one more. Since you already learned the second derivative, right? So if d2y dx2, okay, if d2y dx2 more than 0, less than 0, d2y dx2, you okay, wait, from positive to negative, it going down. It going down means less than 0. This one, d2y dx2 more than 0. If more than 0, d2y dx2 more than 0, it will be minimum point. If d2y dx2 less than 0, it will be maximum point. That means I'm teaching you another method, not from dy dx only. Your textbook is teaching you only one method, dy dx. From positive to negative is maximum point. From negative to positive is minimum point. But now I add one more. After dy dx equals to 0, I don't know maximum or minimum. So I use d2y dx2 to determine. If d2y dx2 less than 0 is maximum, if d2y dx2 more than 0 is minimum point. Okay, so if here point of inflection here, d2y dx2 will be equals to 0. Okay, if d2y dx2 means second derivative equals to 0, that means it's not maximum, it's not minimum, it is point of inflection. And you do one more, third derivative, d is not equals to 0, then it's point of inflection. This one we'll see example later. Okay, next, let's see example 16. The curve here, okay, find the coordinate of turning point. Normally the question asks you to find coordinate of turning point. Coordinate of turning point, you need to find x, y. Remember, coordinate. Okay, turning point meaning, when turning point meaning dy dx equals to 0. Because turning point may be maximum, minimum, or point of inflection. 3 points. One is maximum, one is minimum, one is point of inflection. Okay, next. Let's do this is a curve. Okay, we find dy dx. Remember how to find dy dx? You want to go in front, 3x squared minus 6x minus 9 dy dx. When it say turning point, so I will let my dy dx equals to 0. Okay, when I let the dy dx equal to 0, I can find the x. I can find the x now. So by factorizing it, so whole thing equals to 0, all divided by 3, you will get this divided by 3. and then factorize. When factorize, remember equals to 0. X, so 133. Negative means negative 3 plus 1, negative 2. Therefore, x plus 1 equals to 0, x equals to negative 1, comma, x equals to 3. There are 2 points. So we substitute back to the original y to get your coordinate. When x equals to negative 1, your y equals to, substitute back to your original function, original curve, your original y. Okay, you substitute the negative 1 inside, negative 1 to your original y. And then what you get? Okay, next also, when x equals to 3, you substitute to your original y, you will get the y value, then you can get the coordinate. You put 3 here. Okay, calculator, calculate now. Okay, you will get, here is 16, here is negative 16. Okay, the x and y, the answer one coordinate, so therefore your answer will be one is negative 116, another will be 3 and negative 16. There are two coordinates done. Found the coordinate of the turning point, right? Two information, coordinate your answer finally in coordinate, turning point, dy dx equals to 0. Okay, next, determine whether each of the turning point is a maximum or minimum. Maximum or minimum, so we need to either, okay, follow your textbook. You follow the textbook, you need to find in front and behind, the point before and after. You substitute back into the x. Okay, let's see. Like this. This is negative 1. Just now you found negative 1 and 3. Negative 1 and 3. So I explain what your textbook doing. Okay. Negative 1 is here. 3 is here. It use these two, you substitute yourself. Before and after. Maybe you put 0.5 before and 0.5 after. You substitute the point inside. This two is add by ourselves. Okay, these two add by ourselves, and the x substitute. This one, the x are negative 1.5. We think ourselves, right? And then we use this x substitute to our dy dx. Dy dx. Okay, dy dx, this function. 3x squared minus 6x minus 9. We substitute the x equals to negative 1.5. Substitute to your dy dx. You will find 6.75. Use x negative 0.5 to your dy dx. You will find negative 5.25. So also same. That means you need to substitute 4 points. And this 4 points you think by yourself. 1 and 3 given from the turning point just now. And before and after you think by yourself. Maybe you want plus and minus 1 also can. Plus and minus 0.5 also can. Any number. Okay. Now, these 2 points, this 4 points you substitute to your dy dx. Because you want to substitute what is your dy dx. So you use a dy dx function. You substitute your dy dx, you get this 4 value. Okay, then sign for the value. Just follow the table. Just follow the table. This sign is positive, this sign is negative. So it's positive, it's going up, negative going down. The sketch of tangent is up, 0 down. So the sketch of graph is maximum. That means your point negative 1 and 16 is maximum point. And your point 3 and negative 16 is, from here you can see it is minimum point. Okay, this is what your textbook answer. So it will maximum and minimum. The curve like this, because it's power 3, so it's cubic function. So example 16 is like this. Okay, I'll introduce you one more method. Okay, for example 16, you follow textbook is like this. You substitute x, the x you think yourself, you substitute to your dy dx. And then you find whether what number already, and then you determine the sign, positive or negative, and change your function. If you change positive to negative is maximum, negative to positive is minimum, and never change, it will point your inflection. Okay, I introduce you another method, maybe you want to use this method also can, use textbook one also can. Determine whether the turning point maximum or minimum, right? Okay, so dy dx equals to 3x squared minus 6x minus 9. Since this one turning point equals to 0, I found my x already, right? Negative 1 and 16. If dy dx equals to 0, means turning point. So you got 2 point, this 2 point. And now I want to determine whether the point is maximum or minimum. I differentiate one more time. Okay, second derivative, 3 to 6x from here, minus 6. So now I substitute when x equals to negative 1, d2y dx2 equals to 6, negative 1 minus 6. You will get negative 6 minus 12, negative 12. When x equals to 3, d2y dx2 equals to, use the second derivative, 6, 3 minus 6. You will get 18 minus 6, it's 12. So this one is negative. If d2y dx2 is negative, okay, it will be maximum point. If d2y dx2 positive, it will be minimum point. So now determine whether the turning point maximum or minimum. Therefore, your answer will be negative 1, 16, negative 1, negative 1, 16. Okay, negative 1, 16. I use a negative 1 to substitute to d2y dx2. I get my answer negative. Answer negative means it's maximum point. So, negative 1, 16 is a maximum point. And 3, negative 16 is a minimum point. Okay, this one same with your textbook answer here, maximum, minimum, but I use different method. This one using dy dx to substitute the value. So two methods also you can use. This one using differentiate one more time to find the d2y dx2. That's why I show you in front just now, this one. Okay, so the blue color is the textbook one. Negative to positive is maximum. Negative to positive, positive to negative maximum, like this, turning down. Then this one is minimum. The red color is the method I use, the second derivative. d2y dx2 less than 0, it will be maximum. d2y dx2 more than 0, it will be minimum point. Okay, finish example 16. Okay, now we go to example 17. It's almost the same. Okay, when you see find the stationary point, whenever find the stationary point, you are finding, remember one thing only, stationary point dy dx equals to 0. Okay, now stationary point, and then determine the nature, maximum, minimum, or the point of inflection. So again, what you need to do, you find dy dx equals to 0, and you got the x. After you got the x, okay, determine the nature, you may use the d2y dx2. If it is more than 0, going up more than 0, it will be minimum point. If it's less than 0, okay, going down, less than 0, is going up. Okay, less than 0, it will be maximum point. If d2y dx2 equals to 0, then you need to do one more time, d3y dx2. If it's not equals to 0, then it is point of inflection. Okay, let's see how is it. Okay, A, y, so dy dx equals to 3 to 6x plus 3 to 6x minus 12. Okay, so now this is dy dx, station is turning point, so equals to 0. And now factorize it, all divided by 6, all divided by 6, it will be 2. Here got square. Okay, now factorize x, 1, 2, 2. So 1, 2, 2, positive, negative. Negative means 1 plus 1 minus, and here positive. So here the bigger number is positive. So therefore, x equals to 1, x equals to negative 2. And the point, so I need to find the y also lah. Remember, after you find your x, go and find your y. When x equals to 1, what is your y? Y equals to original here, 2x power 3. This step don't forget, because you are going to find your original point first. Find back to your original y. So when it's 1, substitute back to your original, your answer. Okay, when x equals to negative 2, substitute to your original one. Actually, now you are applying function. You see, this is a function applying the point inside. Revise back how to use a function. Okay, so substitute here, and then use your calculator to calculate the value here. X equals to 1, you substitute inside, and then what is your point? 2 plus 3 minus 12 plus 5, negative 2. Negative 2 power 3, 8, 2, 16, 16, okay, 25. So there are 2 points. One is 1 and negative 2. Another one will be negative 2, 25. These are the turning point. These are the stationary point. Done, but not yet done, because I just finished the first one. Find the stationary point. These are the stationary point. Second question, determine the nature. What are the nature? Is it maximum? Is it minimum? Is it point inflection? So we use either the method in your textbook. Okay, never show the method in your textbook, 17. Okay. Here also show turning point, minimum when this one. This one what I tell just now lah. D2 and dx2 more than 0 is the minimum point. If less than 0 is maximum point. This is what I told you just now. Okay, 17. It use the method. Okay, it never use the example 16 method lah. So okay, so can lah. Because example 16, the method I feel like very you can follow also this one, more understand lah. Okay, but I feel this method is faster, easier. Okay, d2y dx2, yeah, same method with mine, right? Continue. Y is this one, 2x power 3 plus 3x squared minus 12x plus 5. Okay, dy dx 6x plus 6x squared plus 6x minus 12. d2y dx2. Okay, differentiate one more time, second derivative, plus 6. Okay, so now you substitute your x. Just now what your x? 1 and negative 2. So substitute. When x equals to 1, okay, you will get positive. When x equals to, another point is what? Negative 2. Okay, d2y dx2, negative 2. You get negative answer here. This one you will get positive. This one you will get negative. When d2y dx2 positive, positive meaning going up. Here going up, remember here going up. So it will be minimum point. d2y dx2 less than 0, it will be maximum point. So done. Therefore, for A, use back your point, 1 and negative 2 is a minimum point. And negative 2 to 25, this point is negative 2 is a maximum point. Or actually the example 16, I use the example 17 method. So two methods also can use, also can determine the maximum or minimum. Okay, now we see B. Okay, last example for today. Y equals to x power 4 minus 4x power 3 plus 1. So dy dx, because stationary point, dy dx, 4x power 3 minus 12x squared plus 1 no more. So stationary point equals to 0. So you let this equals to 0, and actually you can factorize. Factorize the 4, factorize the x squared. So you get x minus 3 equals to 0. So 4x squared equals to 0. X minus 3 equals to 0. X will be equals to 0. X will be equals to 3. X coordinate. Then from x coordinate, you go back to your original y. You find your y coordinate. Okay. When x equals to 0, your y equals to 1. When x equals to 3, your y equals to 3. Okay, what is the, when x equals to 3, your y equals to negative 26. So remember, write out first what point you have, the stationary point, 0 and 1, and 3, negative 16, negative 26. Okay, so these are the stationary point. Now determine the nature. So easier method, no need to like the change sign for the dy dx. Easier method to second derivative. Second derivative, derive again from here. So 4, 3, 12x squared minus 12 times 2, 24x. This is second derivative. Now I substitute when x equals to 0, right here, d2y dx2 equals to 0. Oh, 0. How? Okay, never mind. I told you before that when d2y dx2 equals to 0, okay, it's not maximum, it's not minimum. It's possible to become point of inflection, but you need to prove it, okay, by using the third derivative. Although it's not in your syllabus, it's not in your syllabus. You learn until second only, but actually it's the same. Just one more derivative. Never mind, later this one hold it first, Okay, when x equals to 3, d2y dx2, okay, 12, 3 square minus 24, 3. So it is equals to, wait, who is admit? Okay. So this is equals to d2y dx. Okay, we put substitute 3 here. What you get? Second derivative. It is 36. Is 36 more than 0? When d2y dx2 more than 0, how? d2y dx2 more than 0 is going up. More, so going up. So it is minimum point. Okay? So therefore, 3 negative 26 is when d2y dx2 more than 0 going up, more than 0 is a minimum point. Okay, now this one 0. 0 negative 1, how? Okay, 0 negative 1, d2y dx2 equals to 0. So I need to do one more step, d3y dx3. It's not in your syllabus, but I think it's okay. Okay, you can see your example in your textbook. You use different method, like the dy dx method just now. Later I show you in the textbook here. Okay, you use this method. When x equals d2y dx2 equals to 0, okay, then you use the method, the example 16 using, you substitute the x in front and behind. This one is plus minus 0.1. Substitute into your dy dx function. You get negative, meaning it never change the sign. If the sign never change, means it is point of inflection. It's positive to positive point of inflection if the sign never change. So it proves that 0, 1 is point of inflection. 3 negative 26 is use the method. This one I use just now, d2y dx2 more than 0 is minimum point. So now this one, if I don't want to use this method, I use another method. Okay, I use d3y dx3 to prove. Okay, 12 times 2, 24, x minus 24. Okay, if I x equals to 0, d3y dx3, 0 here, 24. It got number. It's not equals to 0. Okay? If d3y dx3 not equals to 0, first, point of inflection is d2y dx2 equals to 0 and d3y dx3 not equals to 0. Then, with these two conditions, then 0, 1 is point of inflection. This one, third derivative. Okay? So, first, this one, d2y dx2 more than 0 minimum. Second, 0, -1 is a point of inflection because d2y dx2 equals to 0. Okay? And d3y dx3 not equals to 0. Then only we can say it's point of inflection. So, proof, you can do this method. You can use your textbook here. Okay? dy dx. Go and find one by one and sketch this one. Then you will already confirm this is inflection, or you can very confirm in your this one. Use this method, you can very confirm is maximum, is minimum if you forget about that one. Okay, now let's recall back what I emphasized today. Okay, last already. Okay, if this maximum, maximum and point of inflection and minimum. Okay, what condition? Stationary point when dy dx equals to 0, dy dx equals to 0, it's maximum or minimum. d2y dx2 equals to 0, it may be point of inflection. Okay. d2y dx2 is going down, negative is maximum. Remember like this. d2y dx2 is going up, positive, minimum. Okay? Okay, this one point of inflection, if d2y dx2 equals to 0, and one more, d3y dx3. Okay, I use the same color easier. d2y dx2 is a black color. d2y dx2 equals to 0, less than 0 maximum, less than, more than 0 minimum, equals to 0, it may be point of inflection if d3y dx3 not equals to 0. Then it's point of inflection. Okay, this is the method I teach just now. Your textbook one is using the dy dx only. Dy dx is going up, going down, up, going down, maximum, down, going up, minimum. Okay? And then here, down, going down, never change, is point of inflection.